Okay, so I'm going to talk about an automated demand forecasting model for new railway stations. This came about from my PhD research that actually developed the underlying models, but it was implemented on DAFNI as part of a pilot project, which was an impact acceleration account grant. So what does the model do? Well, it forecasts demand for new local stations. So these stations are network rail categories E and F, and they've typically got less than 250,000 entries and exits per year. And the model is able to forecast demand for individual stations. So there you might have a number of potential alternative locations that you want to consider. But it can also consider new lines. That's where you've got several stations that are going to coexist in the new situation. Another important aspect of the model is that it can do abstraction analysis. So this is where it will consider how much of the forecast demand for the new station is actually new demand and how much of it is actually passengers switching from the station they currently use to the new station. And it can also produce some nice visualizations of the station catchments. Yeah. The actual underlying model is a national trip end model. So the model is forecasting the number of annual trips at a proposed station. So that's the total entries and exits. And those annual trips are a function of the population in the catchment and also a range of other predictor variables. A novel aspect of the model is how the catchment is defined. Because instead of the usual assumption that people will just use their nearest station, this is much more complex than that, because it incorporates a station choice model. And essentially it looks at each postcode and then assigns a set of potential alternative stations for that postcode, 10 alternative stations. And then the station choice model calculates the probability of each of those stations being chosen for someone choosing to travel by train from that postcode. And those probabilities are then used to weight the population of the postcode to assign it to the different alternative stations. And in terms of the other predictive variables, it's including things like the service frequency of the rail service, the number of jobs near to the station, the number of car parking spaces, that type of thing. The tool makes use of open source data and software tools. It uses Ordnance Survey Open Roads as the roads network for routing. The main part of the model is scripted in R. It's maintained on GitHub. But a lot of the analysis actually takes place in the open source database Postgres, utilizing the PostGIS extension and also the PG routing extension. I'll just go through the sort of main steps that are involved to give you an idea. So considering a proposed new station, we'll start by identifying all the postcodes within 60 minutes of that station. We then find the 10 nearest stations to each postcode. We then use the station choice model to calculate the probability of each of those stations being chosen. Then the trip-end model is run to generate the demand forecast. And then finally we run an abstraction analysis if that's needed. And you can suggest which stations you think abstraction might occur from. The actual process is quite intensive, computationally intensive rather. I won't go into the details on here, but basically we're looking to get the table in the bottom right there for every postcode within the 60 minutes of the proposed station. So what DAFNI has enabled is really a step change in the model run times. Parallel processing is employed in the R scripts, and each job runs in a separate container, a virtualized operating system. As part of the model setup, you can specify how many cores to make available per container, up to 30. And typically it takes about 5 minutes for a single station forecast, but that can be much longer for more complex scenarios where you've got more stations and you're doing a lot of abstraction analysis. And that compares, if you were doing a single station on quite a high-end workstation, it might take about 30 minutes to produce that forecast. As part of the implementation as a pilot project on DAFNI, a web application was created by the DAFNI team. So this, because this is on the sort of pilot platform, it does differ slightly from what you've seen earlier that Tom was showing. But it includes a setup screen, which is shown here, for providing the information about the new station or stations. There's an interactive map that enables you to find information about the existing stations and existing postcodes and the populations of those postcodes, and allows you to select where the new station is going to be located. There's a whole job submission page. This enables you to download the configuration that you've set up. So you can then actually edit that offline. It's in XML. You can upload a configuration file and submit the job. You've got job management, which shows you the jobs that are processing or have processed and how long they've taken. And there's quite a detailed log file as well. So you can see any issues that occurred with the job. And then there's visualization, which is mainly around the probability catchments and how they look. So this is showing for a fictional proposed new station in Helston in Cornwall. So it's built up by postcode. So for each postcode, you've got the probability of that proposed station being chosen. In the darker colours going towards red, you've got a much higher probability. So in the red, you've got nearly a probability of 1 that people in those postcodes would choose that station. So to sum up, really, DAFNI has enabled rapid and effective sharing of the model. This is what we see really as the key benefit for us, that it's not just become another siloed model. And it's very easy for work, for research work, you know, at the end of the project, to just disappear really and only be known to 1 or 2 people. So the main benefit of this is that it's allowed us to make it accessible to other people. It's really useful for this type of situation where you want to explain how the model works. If you want to go and talk to interested parties, you can actually show how the model works. It's been used by other students and researchers. For example, a number of master's students have used it for their project work. And of course, there's always the potential to actually link to other DAFNI models. So that could be output from the Station to Modern model contributing to other models on DAFNI, or actually drawing data in from other models. For example, it might be a population forecasting model, for example. We might want to pull that data in. So it's really maximized knowledge exchange and allowed us to have much greater research impact. And there is, if you want to know more information about the model, there's a link there to a YouTube video, which is about 5 minutes, I think, which has got a narration and subtitles as I walk through the whole process of setting up a model and running it. So yeah, so that's me done.